Alright guys, we're going to take a quick break from chapter 6 and do a little bit of review. Guys, we are going to review graphing quadratics today. Okay, and the reason for this, eventually here we're going to get to graphing some functions that are pretty similar. So wanted to take time to graph these before we do that. So I know this was something we hit during e-learning last year and wanted to touch it again. Okay, so worth noting, quadratic function. A quadratic function is in standard form when f of x equals ax squared plus bx plus c. All right. A little bit on graphing. Okay, if a, that leading coefficient there, if a is positive, the parabola, that's the shape of this graph, the parabola opens up. If a, the leading coefficient, is negative, the parabola opens down. And I can give you a visualization. So a parabola that would open up, looks like a U shape, opens down, maybe somewhat like a lowercase n. All right. So that's just a note on graphing quadratics, guys. Other note, this takes 3 steps. Graphing a quadratic takes 3 steps. The first is finding the axis of symmetry. The second is finding the vertex. Guys, the vertex is an x, y ordered pair. And then the third step is making a t-chart. So really pretty simple if you can follow along with these 3 steps. I'll do a couple examples here. Okay. Move this page a little bit so I have some room to graph. So we're going to graph, let's do an example then. Let's graph the quadratic function f of x equals negative 2x squared plus 12x minus 15. We might still need a little more room here, but we can certainly get started, guys. Notice the leading coefficient here. The a is negative, so this parabola should open down. Let's make note b is 12. C, the constant, is negative 15. All right, so that first step, the first step is finding the axis of symmetry. And you might recall, I know this is Algebra 1, as well as, like I said, we covered this in the spring. The axis of symmetry, that's the line that goes through the middle of your parabola. It reflects points across it. Anyway, the formula for that is x equals negative b over 2a. So if we find the axis of symmetry for this quadratic, we've got negative, substitute in b, which is 12, over 2, substitute in a, which is negative 2. Again, using parentheses when you substitute here, so we can get our sign straight here. So we got negative 12 over 2 times negative 2, negative 4. Guys, the axis of symmetry is going to be x equals 3. Okay? So what does that mean? Again, if we're graphing a quadratic, get our y-axis, or x-axis. The axis of symmetry being at 3 means that there is a vertical line here at 3 that our parabola is going to be, shaped around or reflected over, okay? So that is the axis of symmetry, guys. I usually use a dashed line to mark my axis of symmetry. The second step is finding the vertex, as we said. That was an XY ordered pair. The X coordinate of the vertex is that axis of symmetry. The vertex is going to be on the axis of symmetry. So the X value of the vertex is 3. Okay, we need to find that second, that Y value of the ordered pair here. So the way we do that, we want to find f of 3. We want to substitute in 3. So we're substituting that into our function. We're going to substitute 3 in for x. So this looks like -2. Again, substituting 3 for x. So -2 times 3 squared plus 12 times 3 minus 15. Then we're simplifying this. -2 times 9 plus 36 minus 15. This is -18 plus 36 minus 15, which is 18 minus 15, or 3. So the vertex is the point 3, 3. And so we're going to plot that point 3, 3. That is our vertex. All right. The last step is making a T-chart. A little more room here. So our third step is making that T-chart. Okay. And this is going to give us the rest of our points. Okay. So when you do this, guys, take that vertex point, take that 3, 3. That's going to go in the middle of your T-chart. Okay. And you're going to grab the x. We're plugging in x values here, so we need some more x values to plug in. So just pick the points that are right around. I'll highlight these points that we're picking. Pick the x values that are, right next to 3. So what, 2 and 1. We're going to grab those x values. 4 and 5 are on the other side. Okay? So those are the x values. We're picking them, but we're doing so in a really organized manner. We just want the ones that are right next to 3. All right, and then now we're just plugging in these x values. So here we're going to find f of 1. We're going to substitute in 1. So that's substituting it again into the original function. -2 times 1 squared plus 12 times 1 minus 15. Okay, that ends up being, I'm going to do a little mental math here. We got -2 plus 12. That's 10. 10 minus 15, that's going to be -5. Okay, so 1, -5 is a point on this graph. 1, -5. And now I've plotted that point there. Oh, I plotted the point 1, -4. Mr. Hartman's a liar here. 1, -5. Apologies there. And yes, now I have plotted that point 1, -5. All right. Now let's plug in 2. We're going to get -2 times 2 squared plus 12 times 2 minus 15. I'm going to do some more mental math here. We got 2 squared is 4. So that first term is going to be -8 plus 24. 16. 16 minus 15 is 1. So 2, 1 is a point on this graph. 2, 1. All right, so that's half of our parabola. Guys, you can certainly plug in f of 4 if you'd like. Guys, you can use the axis of symmetry just to understand that it's going to reflect. F of 4 is going to be 1. It's going to reflect that point that was at 2. These two are reflections of each other. And then same thing with 1 and 5. You could certainly plug in f of 5 and do all of that work. But you're going to get that it is -5 because it's a reflection. of the other side of the graph, okay? And so that's what your parabola looks like, guys. I, again, encourage you not to have to plug in 2 more times. I just use that reflecting property there. All right. So that is graphing a parabola. I've got one more, little more simple parabola. Numbers aren't quite as big that we'll do another example. So this function, let's go f of x equals x squared plus 2x plus 3. Okay, so a is 1, b is 2, c is 3 here. All right, first step is going to be finding that axis of symmetry. Again, that formula is negative b over 2a. So negative, well, b is 2 over 2 times a is 1. Negative 2 over 2, that's negative 1. So the axis of symmetry, I'm going to graph this one right here. For this one is at negative 1. That is our axis of symmetry. Second step, finding that vertex. So we take that x value of the vertex and we're substituting it in for x in the original function. Going back to that original function. So x squared, so negative 1 squared, plus 2 times x, plus 3. So this is 1 minus 2 plus 3. What are we going to get there? Positive 2. So negative 1, 2. That's the vertex. That's our vertex. Okay, third step is making that t-chart. Working with smaller numbers, the mental math can get it pretty quick here. So negative 1, 2, again the vertex goes in the middle. And now, again, let me highlight here, because we're wanting to pick these x values that are next to it. So 0, guys, that's the value that's bigger than negative 1. And 1 would also be next to it. So 0 and 1, we'll plug those in. And then the other side, the left side of it, what? We'd have like negative 2 and negative 3. Okay. Guys, certainly easier. We could plug in those top 2 as I did on the last example, but certainly easy to plug 0 into a function. So I'm going to do that. If you're plugging that into the original function, you've got 0 squared plus 2 times 0 plus 3. Guys, what's 0 squared is 0. 2 times 0 is 0. So this is just positive 3. 0, 3. That is a point on this graph. That one will reflect to negative 2. Negative 2, 3. And then plugging in 1 is probably easier than plugging in negative 3. The mental math wise, I mean. So 1 squared is 1, plus 2 is 3, 3 plus 3 is 6. So that would be 1 comma 6 is a point on this graph. And of course it'll reflect to negative 3 as well. So this parabola opens up, we got that positive a value. Yeah, okay, use the reflecting property there of the axis of symmetry. And see, we can graph a parabola pretty quick. I think this took us 3-4 minutes here. So, all right, guys. Thanks for watching. We'll have a Canvas quiz here where you guys can answer a few questions about graphing quadratics, showing your work, of course. And tomorrow we'll move into some other more interesting new content. So, have a wonderful afternoon, guys.